Hello everyone, welcome to the video lecture on errors and the calibration in a single phase energy meter system. So in today's video lecture, we will see what are the possible errors in a single phase energy meter and especially in driving system. So the first error is incorrect magnitude of flux. So we know the pressure coil produces a magnetic field. Similarly, the current coil also produces a magnetic field. The pressure coil is because of the proportional voltage from the supply, and similarly the magnetic field in current coil is because of the current produced. So the abnormal values of current and the supply voltage causes incorrect magnitude of flux, and this causes error which changes the resistance, and and it is also because of abnormal frequency. So the incurrent flux is because of the abnormal values in current and voltage, also due to the abnormal frequency. And the next error is incorrect phase angle. So there may not be proper relationship between various phases, but because of improper lagging adjustments and because of abnormal frequencies, changes in resistance with respect to temperature, etc., there is an incorrect phase angle in the driving system. And the next error produced is lack of symmetry in magnetic circuit. So in the case the magnetic circuit is not symmetrical, the driving torque produced in the energy meter will make the meter to move slowly. So the meter moving slowly in an energy meter, we call it as creep. So this creep is produced when the magnetic circuit is not symmetrical. And apart from that, we have errors in braking system also. So changes in strength of the brake system causes error in braking system. Changes in disc resistance causes error in braking system, and changes in series magnetic flux causes changes in errors in braking system, and because of the abnormal friction in the moving parts, it causes errors in braking system. So these are different types of errors present in single phase energy meter in the driving system and also in the braking system. So next is how we can calibrate the errors produced in this energy meter. So the first calibration is preliminary light load adjustment. So in order to achieve this preliminary light load adjustment, the disc is positioned so that the holes does not directly fall below the electromagnet. So the rated voltage is applied to the potential coil with no current through the current coil. So in order to position the holes uh, which does not underneath the electromagnet, so in that time the rated voltage applied to the potential coil, when the rated voltage is applied to the potential coil, we will not apply any current through the current coil. So this is just a adjustment when the disc does not, when the disc fails to start immediately after the rotation. And next adjustment is full load unity power adjustment. So in full load unity power adjustment, we connect the pressure coil across the rated supply voltage and the load current at unity power factor. So connect the pressure coil to the supply voltage and the current coil to the current at unity power factor. Now position the brake magnet so that the braking torque revolves in correct speed. Now after making the connections between the pressure coil and the current coil for unity power factor, next adjust the brake magnet in such a way that the meter revolves in correct speed. So this adjustment we call it as full load unity power adjustment. The next calibration is lag adjustment. So in order to achieve this lag adjustment, the pressure coil is connected across the rated power supply and the current coil is connected to the current at 0.5 power factor lagging. So in the previous adjustment, we connected for unity power factor lagging, but here in this case, the pressure coil is connected across the supply voltage and the current is connected, current coil is connected to the current at 0.5 lagging, power factor lagging. And then the device is adjusted so that the disc rotates at correct speed with rated supply voltage. So next is how we can connect to the rated supply voltage. The rated full load supply current and the speed of the meter is checked at full load unity power factor and low power factor, so that the accuracy is reached at both the condition. So in order to find out whether the rated supply voltage is connected correctly or not, connect the connect the current coil to full load current, and the speed of the meter is checked for both power factors, that is for unity power factor and also for low power factor. Now check whether the accuracy is attained. Next is light load adjustment. So in order to achieve this light load adjustment, the supply voltage is connected across the pressure coil and the current is through the current coil at unity power factor. Then do the light load adjustment to check whether the meter is rotating at correct speed. Next, what we do is, after doing these connections at full load unity power factor, next do the same connections for light load adjustment and then check whether the speed is correct for both the loads. So connect the pressure coil to supply voltage, current coil to the current, and first check it for unity power factor, do the same connection, then check it for lagging power factor and check whether the speed is maintained correctly. And next we do it for 0.5 power factor lagging, and then we do the corrections. Next is creep adjustment. So for creep adjustment, so we know creep adjustment is nothing but to find out whether the disc is moving slowly or not. So if the disc is moving slowly rather than moving at a normal speed, then it is called as creep. So in order to manage this creep, we do an adjustment called as creep adjustment. To do this creep adjustment, excite the rated supply voltage to 110% of rated supply voltage. So increase the supply voltage to 110% at zero load current and find if the meter is running properly or not. So if the meter is not showing any creep conditions at light load adjustment, even after exciting to 110%, then we have adjusted the creep. So these are various adjustments that we should do before starting or before reading the energy meter. So for this particular lecture, the textbook which I have referred is A.K. Sahani, a course in electrical and electronic measurements and instrumentation. Hope this lecture is helpful. Thank you.